This is the male Luer tip that will be glued to the end of the plunger and will be used to screw on the hypodermic needle we got for our demonstration. We started by defining a circle sketched on the front plane and centered on the origin with a diameter of 8.25 millimeters. Now, according to ISO standards, the interior diameter is 8 millimeters, but since we were printing this piece, we added a 0.25 millimeter sliding friction tolerance so that the female Luer end of the needle could easily screw in without there being anything causing it to get stuck. And once screwed all the way to the bottom, it holds nice and tight. Then, with this circular sketch, we extruded it out 5.5 millimeters, which matches the depth required by ISO standards. Now, with this structure, we shelled it outwards 1.75 millimeters. Now, the ISO standards gave a broad range for this. We set it as 1.75 as it is thick enough to, compared to the rest of the structure to have a nice structural hold. Then, for the threading, Luer threading is very specific and customized, so we had to create our own threading profile. So what we did is we copied the threading profile that's already existing in SolidWorks, and then we changed the numbers to match the ISO standards of Luer threading. So that is a 60-degree angle with a 0.5 millimeter height and a 0.3 millimeter land width, as well as a 2.5 millimeter pitch. Then with this threading profile in SolidWorks, we used Hole Wizard to create a thread from this edge, the interior edge on the end of this male Luer, all the way to this back surface. And we used a extruded threading, so it extrudes from this interior surface, and it is a double right-handed thread, so it's double start, as you can see here, 180 degrees apart, right-handed thread, as required by ISO standards. Lastly, the threading is 5 millimeter pitch, as according to the ISO standard, every one turn it goes 5 millimeters in. And then we had the threading end flush to the back face so that it is nice and smooth.